you on how to use the bisection method to find the rightmost root of the function below. First, we will make a table with 11 columns. Each column are used for value of A, function of A, value of B, function of B, value of C, function of C, FA times FC, FB times FC, and error B minus A, and lastly, root present between A and B. Let's start with the first example. First, we set our iteration from 0 to 6. For I0, set the value of A as -1. In column FA, use the function given and substitute the value of A. Value of B is the positive of value of A. Use the same function to find FB. C is the midpoint of A and B, so to find C, A we plus with B and then we divide it by 2. Then substitute the value into the function to get FC. To find FA times FC, we will write down the equation, which is we select a cell in FA, asterisk, select a cell in FC, then we press enter. For FB times FC, we will use the same equation, which is select a cell in FB, asterisk, select a cell in FC, enter. To find an error, we just write cell in A, we will minus with cell in B. For the next iteration, there are 2 rules to be followed. First, if FA times FC is more than 0, value of C0 will be used as A1 and B0 will be used as B1. Second, if FB times FC is more than 0, value of C0 will be used as B2. Since FA times FC is more than 0, therefore I1 will follow the first rule. It continues as the value keeps on positive. In I2, the value of FB2 times FC2 is positive. I3 will follow the second rule. Value of C2 will be used as B3. Keep using this step until you get an error is lower than our acceptable value. Then we are done. We can also visually depict our function in boundaries in the following ways. We can also create small steps in the x direction. Let's put up -1, then 0.02, then drag the sequence down. Then we go with our initial boundaries by substituting the small steps into the equation. Next, let us create 2 points in space to visualize our lower root boundary. Highlight both of the boundary, then add the line graph. Let's find out the higher and lower boundary at iteration 4. Now we have just completed our problems using the bisection method. Another cool thing that we can do is to add a validation that we have a root within 2 boundaries. Create an if or statement which states that FA times FB or FB times FC is less than 0. We can print true, if not, false. That is all from us.